clear? Sorry. Okay, now once again, what's a dielectric? Dielectric is a material which is neutral in a zero field and gets polarized under an external electric field. Okay, initially it is neutral, and when it is placed in an external electric field, it gets polarized. Okay, right. I used the word polarized many times here, but only once in the definition, right? Okay, I might have repeated the definition number of times. Okay, so many number of times I use the word polarized. Can you tell me what do you mean by polarized? Okay, you tell me what do you mean by, yeah.
Negative charges moving
Mm.
towards positive.
Mm-hmm. Mm. Okay, right,
In
right, yeah. Mm.
opposite of external field.
Yeah, okay, good. Good, ma. Okay. Polarization implies separation of the charges. Okay. What are the two kinds of charges available in the world? Okay, there are only two kinds of charges. Okay, positive charges and negative charges. Okay. So when you said that material is neutral, when you say the material is neutral, okay, that implies the total number of negative charges and total number of positive charges are same, and the center of negative charges is same as that of the center of the positive charges. So the material is generally considered as neutral. So material is generally considered as neutral. Now what happens when you polarize? When you polarize, what happens is negative charges of the material move to one side and the positive charges of the material move to the other side, or to say, okay, in opposite direction. Now when this happens, we say that the material is getting polarized, or when the material got polarized. Okay, so for the material to get polarized, you require the material to have positive charges and negative charges. Can you tell me, okay, a material which does not have positive charges and negative charges? Yeah, do we have any material which does not have positive charges and negative charges? 5, 4.
Plastic, sir. Neutrons, sir.
Emma?
Plastic wood. Neutrons.
Nuclear.
Okay. Okay. So I'll take one by one. Okay, I heard three answers, so I'll answer. Okay. Neutrons. Neutrons are actually made up of quarks. Okay, which have positive and negative charges with them. So it's also made up of okay, charged particles. Right. Coming to wood. Wood is made up of carbon. Okay, carbon has protons and electrons, so it also has got charged particles. Plastic, okay, is generally a hydrocarbon. Again, hydrogen has got protons and new electrons, and carbon also has got protons and electrons. So that's also. Can you? And further. Come on, 5 more
Sir,
seconds.
no
5.
element in the world is present without made,
No
made of
element.
an element.
Very good, very good, very good. Okay. Yeah. Can you tell me a particle which is neither positive nor negative and does not have any negative charges and positive charges? 5, 4, 3, 2, 1. I'll repeat the question. Can you tell me a particle, okay, which does not have negative charges and positive charges in it? 5, 4, 3, 2, 1. What happened? Do you want me to hint you?
No,
Okay, good. Somebody
all of
said.
them have, but
There is no
both are balanced, so they become neutral.
Yeah, true. Understood. Okay, your argument is good. Okay, okay. You say that all of them have negative and positive particles, but they are neutral. Okay. Now, first unit. What is our first unit?
Wave optics.
Okay, from that, can you say something? Can you say something? 5, 4, 3, 2, 1. What's the answer? Photons. Photons are also particles. Kada. Classical classical perspective, they are waves as well as particles, right? Light is wave as well as particle. So the particle of wave is nothing but your photon. Okay, right. Okay, okay. I mean, just a particular perspective ఇవ్వడానికి మాత్రమే ఆ క్వశ్చన్ అడిగారు, nothing much. Okay, right. All electromagnetic radiations are quanta. Okay, that is photons, and these photons do not have negative and positive charges. That means they are not made up of any other further material. Okay, so they are all you can say do not have negative and positive charge particles, right? Sorry, coming back to material particles. Okay, classical material particles. Photon is not a classical particle. Okay, it's a quantum mechanical one. Okay, now if you come to the general classical mechanics, we don't have any material which does not have positive charges and negative charges. Then do you mean to say that all material can be said as dielectrics? Answer is no. Why, sir? You just said, and you, as per your definition, every material is made up of positive charges and negative charges, and they get And so when you apply an electric field, obviously negative charges will move to one side and positive charges will move to the other side, and so there it is getting polarized. And if it is getting polarized, okay, it should be dielectric. Okay, argument is 100% true. Okay, but the problem is when I apply some electric field to a metal, it is the electrons which will move from one side of the material to another side of the material. Okay, and they physically move long distances. Okay, based on the applied electric field. Okay, based on and their size is very small and the distance they traveled is very large. So that way, there will be motion, physical motion of electrons from one place to another place. This actually leads to conduction. Okay. Now you may ask, does the material get polarized? Yes. What is the net electric field inside a metal? Okay. This is the question that you might have been taught in your intermediate second year. Okay. What is the electric field inside the metal? 5, 4, 3, 2, 1. How much? Once again, 5, 4, 3, 2, 1. How much? Okay. Did you did you not hear? Did you not know that field inside? Okay, field inside a metal cylinder. Okay, field inside a metal cylinder. Ah, that's it. That's it. Why? Why? Because it produces a
Electric
field.
lines are
Right.
perpendicular
Yeah, electric lines are perpendicular to.
to the metal surface. Yeah.
Okay, so okay, your answer is right. Okay, your answer is right. Your answer is right that the electric field
As
inside a
charge
metal cylinder
present
is
on
zero. Ah, right. Okay, this part of argument is right. Okay, your answer is right that electric field inside a metal cylinder is zero, and the argument is that it is so because the metal will produce a field exactly equal and opposite to the applied field within itself, because of which the net field inside the material becomes zero. So the net field inside becomes zero. Okay, yeah, they are also acting like dielectrics, but we don't call metals as dielectrics. Now, what's the reason, sir? Okay, nothing particular basically. Only thing is, okay, first people tried, okay, named some of the things, and then they understood what they are doing. Okay, then they did not correct and they carried on with the same names. Okay, yes. In metals also, the charge is moving from one side to another side and it is getting completely polarized and the field inside is becoming zero. Okay, the field inside is becoming zero. Why? Because the charges are getting separated and a new electric field is getting created inside the metal, and that field is equal and opposite to the applied field, and so it's becoming zero. Okay, but the same thing is happening in dielectric materials also. But here the electrons are not displacing themselves from one place to another place. Okay, there is just a small change in their center of charges. Okay, as you see the picture over here, I'm trying to magnify it. Okay, what's happening is, okay, this is generally a spherical atom or molecule. Okay, and when an electric field is applied, okay, what is the electric field direction? From which side to which side? Electric field direction is from?
Negative to positive.
Okay, good. Yeah, do you all agree or not? Electric
Yes, sir.
line of force is from?
Always away from the positives.
మరి ఇందాక చెప్తే మరి కరెక్షన్ ఎందుకు చేయలేదు? It's every time away from the positive charges towards the negative charges. Okay, so the electric line of force starts from the positive charge and ends at the negative charge. Okay, now the line of force also gives you the direction in which a unit positive charge would move. The line of force actually gives the direction in which a unit positive charge would move. Okay, so that line of force is every time from positive charges to negative charges. So as you see here, the left hand side electric, okay, metal plate, okay, left hand side metal plate will have positive charges, and the right hand side metal plate will have negative charges. So you will have negative charges on the right and positive charges on the left, because of which there will be some lines of force generated. Okay, right. What will I do is okay, I'll come back to this, but first I'll go to the previous, sorry, next slide and come back.